Okay, so suppose I was trying to find the derivative of the natural log of 2 plus x divided by x to the ninth power. So the first thing I realize here is that this is a quotient, so I'm going to have to use the quotient rule. And now I need to identify my u and my v. So it looks like this is u, the natural log of 2 plus x, and x to the ninth is v. So now I'm ready to actually calculate u prime, which is, since I have the natural log of 2 plus x, I see that there's a chain rule there. So the derivative of 2 plus x is 1. And the derivative of natural log of anything is 1 over the natural log of the argument. So that's 1 over 2 plus x. So I didn't really need the 1 there, but I put that for emphasis so I would know what that was. V prime is then going to be, since I have x to the ninth power, then v prime is going to be 9x to the 8th power. Alright, so we'll come back to this in a minute, but remember our quotient rule, derivative of u divided by v with respect to x is equal to u prime v minus u v prime divided by v squared. So, just to remind myself, u is the natural log of 2 plus x, v is x to the ninth, u prime, I'm going to write that as just 1 over 2 plus x, and v prime is 9x to the 8th power. So, u prime is 1 over 2 plus x times v, which is x to the ninth power, minus u, which was the natural log of 2 plus x, times v prime, which was 9x to the 8th power. Put that in brackets so that we don't think that's part of the argument. And then that's all divided by x to the ninth power squared, so that'll be x to the 18th power. Alright, so there could be some simplifications that could be done here, just to clean up a little bit. So I have x to the ninth over 2 plus x minus 9x to the 8th times a natural log of 2 plus x. And then all of this stuff, I'm going to write it like this, is divided by x to the 18th power, so that's times 1 over x to the 18th power. So we see we have some common x's here. So I'm going to be able to factor out an x to the 8th power. So I'm going to do that on the next page. We'll come back and forth so we can remember. So this is going to be equal to a common x to the 8th power comes out. Remember, in our denominator we had x to the 18th power. And then what do we have left up here on the top? Up on the top here, if I pulled out an x to the 8th, for the first term I have an x over 2 plus x. So I'll have here now x over 2 plus x minus, let's look at that second term again. So over here I pulled out an x to the 8th power, so that leaves me with 9 times the natural log of 2 plus x. So minus 9 times the natural log of the quantity 2 plus x. Okay, so these x's over here are going to cancel nicely. So 8 of them are gone from the top there, and then that leaves me with 10 down here. So that'll be power of 10 there. And then I need to get a common denominator for this part here, which is going to be 2 plus x. So finally I'm going to be getting close to being done here. That's going to be 1 over x to the 10th power. That's in the denominator. Then simplifying that numerator, I've got a common denominator of 2 plus x. This first fraction is already over 2 plus x. The second fraction over here will be over 2 plus x if I just multiply it by 2 plus x. So that's minus quantity 2 plus x times 9 ln of 2 plus x. Now I want to be real careful because these 2 plus x's can't be combined because one is the argument of natural log and one is not. Okay, so finally let me just clean it up so it looks real good. So in the numerator I'm going to have x minus 9 times the quantity of 2 plus x natural log of 2 plus x. In the denominator I have this 2 plus x here and this x to the 10th power, so they go together nicely. And so in the denominator I have x times the quantity of 2 plus x. And just double checking to make sure that I got everything. Well, that should be x to the 10th power, right? Good, x to the 10th power. Thank you. And now I have my solution.